All right, 4-1, inverse variation and reciprocal function. So first, an inverse variation, y equals k over x. So we read this y varies inversely as x. And so k is called my constant of proportionality. So one way to find k, and that's what we'll do to set these up, but one way to find k is, first of all, solve for k, especially if they give you a bunch of x and y's, or even just one. And to solve for k, I multiply both sides by x, so k is actually equal to x times y. If I multiply by x over here, that gets rid of it, and x here makes that xy, and so k is equal to xy, which means if I want to find k, see if this is an inverse variation, I multiply these two together and see if I have a constant of proportionality. In other words, are these all the same number? Is k consistent as I move through this table? And it is. All right, so that means yes, this is an inverse variation. All right, so let's look at this next problem. In an inverse variation, x is 6 and y is 1/2. What's the equation to represent the inverse variation? First, I need to find k. So I want to write this equation, but I need k first. And I know to find k, I can multiply x and y together, and they gave me x and y. So k is 6 times 1/2, or half of 6, and so that would be 3. So y equals 3 over x is my inverse variation equation. All right, so what's the value of y when x is 15? So I plug in 15 for x, and y is 5. And that's the way you do inverse variation problems. All right, so let's look at the graph of 1 over x, just super quick. So if I want to graph y equals 1 over x, I would really like to be able to find key features of my function to be able to sketch a graph. So this is the reciprocal function, or the inverse function. When I try to find x-intercepts, which means I plug in 0 for y, I don't get any x-intercepts. There's no way this is ever going to be equal to 0 because x is on the bottom, not on the top. And so to find x-intercepts, I can set the top equal to 0, and I don't get anything. So it's never going to hit the x-axis. In fact, when x is 0, my function is undefined, which means I have a vertical asymptote. So anytime anything that gives you a 0 in the bottom of a fraction, either we're going to have a vertical asymptote or we're going to have a hole, which we'll get to those later. So I have a vertical asymptote at x equals 0. It's always an equation of a line. X equals something. Horizontal asymptote talks about end behavior. So as x goes to negative infinity, what is y going to? Well, if I plug in really small numbers for x, like negative 100, negative 1 over 1,000. So I'm plugging in negative 100, which gives me negative 1 over 100. I plug in negative 1,000, negative 1 over 1,000. That's going to 0. This number is getting really small as I plug in negative numbers, moving toward negative infinity. As I go towards 0 and I plug in numbers super close to this, to x equals 0, like negative 0.00001, this is going to shoot toward infinity. And you can graph this on your calculator for sure. But I have a horizontal asymptote at y equals 0. Sorry, I put that in the wrong spot, so erase that. All right, when I plug in values for x that are negative, it's going to spit out negative values. So I'm down here in quadrant 3. When I put in values for x that are positive, I'm here in quadrant 1. All right, going toward that horizontal asymptote. Graphs won't cross a vertical asymptote. They can cross horizontal, but usually don't. They just hover it. All right, so this is a basic graph of the reciprocal function 1 over x. Again, you can make a table and plug in values for x and see what you get for y and plot those. and you will get this picture on this side, and then I can plug in positive values for x, and I'll get this picture on this side. All right, see you guys soon.